Hi guys, welcome back to In Case of Econ Struggles. Welcome to another exporting results struggle. Today what I've got for you is a new sort of different way of presenting robustness from your estimates. It's also a really easy way to present the results from a lot of different model estimations in one single graph. So this is what we call a specification curve. And so this, for example, is just a bunch of different ways trying to estimate the effect of miles per gallon on price using the auto data set in Stata, where each one of these dots is going to represent the coefficient from a regression. Now, the type of regression and what I'm including in the regression is going to change, right? So whether or not I include controls, whether or not I use classic standard errors, heteroscedastic robust standard errors, or clustered standard errors based on the brand of the car, whether I'm using an OLS regression or an IV regression, those are all different choices that I can make. And basically what I'm showing on this curve is how my coefficient and how my standard error, which are these little bars here, so how my coefficient and how my standard errors change as I change sort of what I'm including in the regression, how I'm doing my standard errors, and whether I'm doing an OLS or an IV. Now, of course, there's broader implications. I could have many more different types of specifications, many more estimates on this graph, but this is what I'm going to use in today's example. And so the way the Stata code is going to work is basically what we're going to do is there's going to be three parts. So first we need to make all of these estimates. We're going to store them and I'll show you how to do that. And then this graph is basically in two parts, where the first part is this top part, making each dot and their standard error bar. And the second part of the graph, the second part of the code, is making basically all these dots down here and choosing which ones are not colored in and which ones are colored in. So again, I'll point that out as we go through the code. Let's go ahead and dive into the Stata code. So now that we're diving into the Stata code, of course, the first thing we need to do is estimate our regressions. So I'm pulling in the auto data. I'm just making this brand variable so that I can do my clustered standard errors by manufacturer, by car brand. So that's what I'm doing here. And now we're going to get ready to sort of collect these coefficients. Now there's a lot of different ways that you can store regression coefficients. Personally, I think the easiest way is with these sort of temp files where I temp file coefficients. And I start with an empty data set, I run some regressions, I store some estimates, and then I put it in this data set. If you've got suggestions for others on how they can store their regression results in a similar way, feel free to throw that in the comment section below. Now we're going to go ahead, I'm going to split this up and do my OLS regressions separately from my IV regressions. So for example, I'll just start with my basic OLS regression, and then after I run the regression, I can basically store the coefficient on miles per gallon and the standard error miles per gallon in these locals, so I'll call them B and SE. Then I can add robust standard errors, and I'll maybe call this slightly different locals, so B underscore R and SE underscore R. Whatever is helpful just to help me remember when I put this in a data set. And then here's the cluster. So then what I can do is I can do an additional regression where now I'm just adding different controls into this regression. But again, I'll do the same sort of three different regressions where I do standard errors or classic standard errors, heteroscedastic robust, and clustered by brand. And then maybe just for fun, or also run some models with foreign and car brand or fixed effects for foreign and car brand. And again, with classic, robust, and clustered standard errors. So now that I've run all of those different models, what I need to do is I need to get ready to save my data set out so that I can call up these coefficients later. So what I'm going to do is first I'm going to preserve, this is really useful again if I am working with data that takes a long time to read in. Here it's not as big of a deal, but depending on your data set, this might be helpful, might save you some time. I've got 9 different estimates that I'm running with OLS. My outcome is price. I'm just using this in case you guys are doing this with many different outcomes. You want to make a specification curve for each outcome. This will help you later just to determine which rows of this data set are for which outcome. The method, I'm using OLS. I'm just going to do these standard errors just so I can remember, so I can easily look back at this data and figure out which estimates are using which type of standard errors. This is telling me to say no for controls for observation number 2, 5, and 8, and then fixed effects in 3, 6, and 9. Again, whichever way you would like to sort of make these controls variables, feel free. And then what I'm doing is I'm just going to go ahead and fill in the appropriate coefficient using those locals we made earlier, and then the standard errors using the appropriate standard errors that I made earlier. Now that I've got all my OLS, I'm going to do my IV regression, and so it's going to be the same sort of deal, same set of controls, same set of standard errors, robust standard errors, and clustered standard errors. And I'm going to do the same thing where I set up my data set, and I should be all set to go. So let's just go ahead, let's run all of this together, and we'll make sure that our data set looks okay. Again, if you've got something that takes a lot of time, you could always make this quiet. So you could always do it quietly for all of these regressions, just so it goes a little faster and you don't have to see all this output in the command window. And now I've gone ahead and opened up my data, and I'm just looking at it, and you can see that we've got exactly what we want. So here's our outcome, here's our method, I0LOS. Type of standard error, I just left it blank if I'm not doing any sort of fancy standard errors. I could have put classic or homoscedastic in here and it wouldn't have mattered. Whether or not I'm using controls, whether or not I'm using fixed effects. One thing to note, I'm always using controls and fixed effects together. You can imagine additional specifications in which you don't use controls but you do use fixed effects. I just didn't do that because it was going to make this a little more complicated, but of course that's something you could do. You could run any combination you want, and then you would just have additional estimates for specifications in which you don't use controls, but you do use fixed effects. So now we're getting ready to sort of set up our code to make the specification curve, and I'll just pull it up again. So for example, the first thing maybe we want to do is we want to use indicator variables for each of these categories, so that we're going to use those indicators to basically turn off or turn on these dots here. So for example, I'm going to generate some binary variables for OLS and IV, and so those are going to be ones or zeros. I'm going to use the same sort of deal for controls and for standard error estimation. And for controls, I'll say no controls, covariates, or fixed effects, and standard errors will be standard, robust, or clustered. And now what I'm going to do is I'm going to sort these, because one thing that's really nice about a specification curve is that as you move from left to right, the estimate gets bigger, so you can see exactly how much variation you have in your estimates, and you can also easily tell what sort of models give you a higher estimate than a lower estimate. Just makes it a little easier to read than if they're going up or down. Then, in order to generate those bars for the 95% confidence interval, I'm just going to take the coefficient and add or subtract 1.96 times the standard error, just to make it easy. And then I'm going to generate basically ranks in order to plot this later. So now we have a local color, which I'm just going to say this is the light gray color that I'm going to use for my dots, and also for my coefficients that I'm not necessarily highlighting. One thing to note about this graph is I personally, maybe perhaps, have sort of a prior that my preferred model is going to be a model in which I include covariates and fixed effects, where I'm using cluster standard errors, and when I'm doing an OLS estimate. So because of that, I want to highlight that specification. So what I'm going to do is I'm going to say that's sort of like my special specification, which I'm going to go like this. Okay, so that's going to be my local special specification, which I'll call later, because then I'm basically going to graph everything up to the specification and then everything after together. But I just want to make this black instead of gray. And so now what I'll do is I'll go ahead and just run this all the way through what I've got, just so that we can see what's happening. And so you can see, for example, that my specification is 18, and I'm going to, the plus one is 19, and the minus one is 17. And now what I want to do is I want to look at the upper confidence interval and the lower confidence interval, because I want to figure out where our buttons want to start, and I want to set up my y-axis. Because if you look at this graph, what's happening, the 2,000 and the minus 4,000, that's what we see here in terms of plotting our estimates and our standard errors. But these guys right here, no controls through IV, those are also using the same y-axis. They're just at values that are lower than minus 4,000. And so what we need to do is we need to set those values such that we have this nice spacing between them and we have a little bit of a break between different categories. And so I'm going to use this sum to say, okay, well, the lower confidence interval, the lowest of the lowest confidence interval is minus 3,800. So maybe I'm going to go 4,000. And the largest upper confidence interval is basically 1,500. So maybe I'll do 2,000. Now, of course, you might just want to let Stata decide what to do for this, but I think it's a little easier just to set your y-axis on purpose, because then you can sort of tweak it and you can make sure that your chart is nice and readable. So now what I'm going to do is I'm going to define a bunch of locals, and I'm going to use those locals basically relative of each other to figure out, for example, I'm going to start my no controls button at minus 4,500, and I want my covariate, so the button for covariates, to start 250 below my no controls. The reason this is nice, because suppose I change where I want this to start, well then everything else is just relative and I don't have to go through and change everything else. And you can see that what I've done here with this 500 versus 250 is again just to make sure that I have a little extra of a gap between categories. Now we're ready to set up the bottom part of the graph and to make these sort of like whether or not we're going to turn off a button or turn on a button. What we're going to say is first we're going to plot a button for everyone. So this is going to be for each estimate, we're going to make this gray dot. So this empty gray dot here. And then if our category matches, so for example, if we're talking about no controls, if our given specification uses no controls, then we are going to fill in that circle with black coloring. And so that's how we're going to turn it from gray to black. Now what we're going to do is this IND thing is just telling us to make sure that when we plot on this y variable, we're making sure that we're in line with the other dots for that same category, so for no controls, covariates, or brand foreign fixed effects. And so we're going to basically do the same thing for our standard errors category and for our method category. Again, you can mess with which order you put these in. You could put OS on top, and then controls, and then standard errors. It doesn't matter. It's just whatever you sort of feel like. And now that we've done that, we want to do the top part of this graph. And for the top part of this graph, what we're going to do is for everything below or before our special specification, we're going to use this code right here. Now this code, what it's doing is it's doing a local, but it's basically going to recursively define this local. So for n equals 1 to our special specification minus 1, so all the way to 17, we're basically going to keep expanding what this local graphs thing looks like. We're going to keep adding to it. And what we're going to add to it is basically this two-way command, where we're going to do a two-way command for scatter. So we're going to put this dot, we're going to put the coefficient and the specification ID. If the specification ID is not our special specification, basically, it's going to be gray. It's going to have gray bars. We're going to add this R cap. This R cap is making our error bars up and down, and we're going to make sure that our dots are small. Now for the special specification, what we're going to do is basically the same thing, except we're going to make sure that the color is black, and for the bars, they're going to be black as well. If we had any specifications after our special specification, again, we would basically just add to our graphs to make sure that we get all those specifications together. And now we're basically ready to put it all together into a two-way graph, where I'm going to graph two-way, where this is going to be everything that's not our special specification. This is our special specification. This is laying down all of the dots below this graph, and this is choosing which of them to fill in. I put a y line at 0 just to make it a little more clear. You don't have to. No legend. This is the part where I did the y label myself from 2000 to minus 4000. And then here's where I'm actually setting the names of the categories that you see on the bottom of the graph. And then I'm just doing some options. I don't want a title because I'll fill that in LaTeX myself. I like the white background rather than Stata's weird blue color. Same thing for the region. And then I'm ready to go and I can export it. So if I go ahead and I just run everything together, you can see that what we're going to get is that same graph that we saw before. And here's what it looks like. So again, I know this code is super complicated. I'm going to put it in the comment section below. If there's particular parts that you're not sure about or you can't figure out, or that maybe you have suggested improvements to, feel free to put that in the comment section below as well. And if you use a specification curve in something, please let me know that in the comment section as well. So as usual, if this video or these videos in general are helping you out, please like and subscribe. We'll see you next time for another case of econ struggles.